This is also a logistic question, and it's asking it in a different way. It gives a different formula. Now, let's look back at the beginning of the notes. We had the rate of change of y with respect to time varies jointly with y and the difference between L, the carrying capacity, and y, which led us to either of these, normally this one, sometimes this, it depends. And then that leads to this, okay? So first problem that dealt with mooses, we ended up using this formula. This problem, we're dealing with catses, and we're dealing with one of these. Let's see which one we're dealing with. Growth rate of population P of feral cats in an abandoned warehouse is modeled by this differential equation. Not enough resources in a warehouse to perpetually sustain growth of population of cats. So we have the rate of change of population equals, the rate of change. So that's why we're here. We're not here. And then they start giving us some stuff, and let's see what it looks like. Well, first of all, that's not a 1, that's a 150. So we're not here. We must be here. And I noticed that L is 150, K is 0.007, and T is measured in years. So let's just kind of go with that idea. I'm going to just write a few things over on the side. I know that K is 0.007, like James Bond, and L is 150. 150 cats, if you want to get technical about it. That's how many cats this warehouse will sustain. So what is the carrying capacity for feral cats in this warehouse? I think we just answered that question, 150. Okay, what is the cat population? Final answer is going to say P equals something, right? When the population is growing the fastest. When is the population growing the fastest? Let's think about this graphically, and we've addressed this before. Back to the very first graph we ever drew. First graph. All right, slope is not 0, but pretty low. And slope is increasing, slope is increasing, slope is increasing. Point of inflection. Concavity changes. The slope is as steep as it's going to get, and then it starts leveling off again. So it is there. That is at half of the carrying capacity. So when is the cat population, when is the cat population, what is the cat population when the population is growing the fastest? So what is that population? It would be at half of the carrying capacity, which is 75 cats. I was having a hard time reading that. It's like, wait, bad grammar. No, just struggle to read. What is the rate of change of the population? Okay, final answer is going to be dp dt. So dp dt, and that is equal to growing the fastest. Okay, growing the fastest when we have 75 cats. And that is going to be, let's see, 0.007 times the population. Population, what is the population? 75. And then 150 minus 75. And this is going to be measured in cats per year. So at its highest growth rate, which is half the carrying capacity, let's use a different graph. It's the steepest graph, steepest slope right there. That is going to be what I get when I type all this in the calculator, and I will save you the trouble. It is 39.375 cats per year.